It's an honor and a privilege to be with you today. As was mentioned, my name is Gregory Green. I am a solution engineer with VMware, part of the data pre-sales team. I'm joined by my colleague, Demetrious. Demetrious, you want to introduce yourself, sir?
Oh yeah. Hi everyone. My name is Demetrious Robinson and I'm a software engineer with VMware's Tanzu Labs.
And Demetrius and I have been pairing on a series of apps based on the Kotlin programming language and Spring Boot. And our applications have been showcasing sort of Internet of Things, edge-based use cases. We wanted to start this conversation. We have a lot to cover. So I'm hoping that we can show you some things and still have some time to open it up for questions. But we wanted to start with the general problems that we want to focus on for today's conversation. So Demetrius, go ahead, take it away.
Yeah, so I'm gonna give you a quick example of an instance where you may encounter problems that RabbitMQ can help you solve. So say we had a single application and a single data store. Well, that application needs to get the information to the data store somehow, right? And in today's modern world, there's a few concerns with that. For one, it's hard to scale due to the many concerns in your application, and it also could be challenging to scale up your data store instances. High throughput can also overwhelm traditional databases. Another problem that makes it hard is that it is hard to implement reliability. We don't control outages and things like that. So for the most part, when we do have outages, we're experiencing like lost messages. So, and it can also be hard and time consuming to reliably implement retry logic for cloud native applications.
All right, and thank you so much. And I hope that some of those issues resonate with folks in the audience. So as Demetrius outlined, how do you go from hard to scale to somewhat easy, I wouldn't say totally easy, but easier to scale? Well, I think that, I think that in general, separations of the concerns come naturally when you start introducing a product message broker like RabbitMQ, because you're separating applications that are focused on sourcing the information from some system of record, from some sensor, and they may be also have the added responsibilities of doing some sort of validation, some structuring before they send that over the wire, so to speak, or over the internet connection to a broker. The broker is responsible for sending that information or providing an abstraction layer to send that to a consumer. And the consumer in this case, as Demetrius mentioned, right, in our example, we want to ultimately send that to some data store. So the consumer can be the experts and to know how to communicate with that data store. And the producers in this case don't need to know all of the nitty-gritty details and the best practices in order to do that. Another aspect of scalability is obviously within the broker itself. So you can increase the number of nodes and they to handle more and more producers and more consumers in different message types that can be stored into different queues for different destinations. And for the consumers, you can increase the number of consumers and they can work in conjunction to increase the overall throughput for message processing. And this can overcome a common issue that we see within RabbitMQ is this problem of slow consumers. And consumers may be slow for various deep reasons, implementation details, resources on the actual environment that they're deployed on. But you can overcome that in many cases just by scaling up the number of consumers that you have. And I should also mention that you can scale up any one of these tiers from the producer, the broker, and the consumers. Now, from a reliability point of view or resiliency, the brokers, if they're deployed in a cluster, and many of you are already familiar with best practices of Rabbit, we recommend a quorum number of brokers. So that means an odd number, 3, 5, 7. And they sort of look out for each other, as I like to say. They watch out in terms of if one of them is having an issue, the other one can kind of step in. And you also want to build in multiple layers of redundancy for your messages. So again, if you have an issue with a minority number of nodes, your producers and your consumers can be abstracted or shielded from this issue, all from within the broker. And when you are talking about reliability in RabbitMQ, the broker has a huge chunk of the responsibility to reliably deliver those messages from point A to point B, but it is not solely the responsibility of the broker to implement reliability, right? And you want to be doing things like, for example, doing publisher confirms in your producers, and also acknowledging in your consumers that, hey, I've successfully now stored this information into my data store. So now this message can safely be removed from the broker. And if that does not happen, for whatever reason, maybe there's a network outage or a network hiccup, or maybe the data store is having some sort of performance issue, your consumers should not acknowledge those messages and keep them on the broker, and the broker can re-deliver them at a later point in time. All right, and we want to show you some of these examples from a demo. And in our case, we are demoing Internet of Things, and this is sort of like in a connected vehicle or connected car scenario. So the data that we've been sending over the wire is vehicle information. It has some unique identifier. It also has some statistics like the odometer, the speed, and the temperature, along with the position of the vehicle. We're going to have a generator app, and this generator app is going to simulate generating multiple sets of vehicle data. So think about a fleet management system where you may be pulling this information in batch based on a schedule of what is the latest and greatest statistics from various vehicles and various locations. We're going to send that over the wire using AMQP protocol to a RabbitMQ cluster. And this is also going to have multiple consumers. These consumers are going to store it into a NoSQL in-memory data store called Apache Geo. And we have a dashboard that's going to provide a visualization of this information. All of our examples are going to be running in Google Cloud. Right. So Demetrious and I, we already provisioned some things, like we provisioned a RabbitMQ that's currently running. We're using the operator, the Kubernetes operator, and we're providing it the specific Docker image that has the streaming plugin already enabled. And the replicas here is we're deploying it over 3 nodes in Kubernetes.
Hey, Greg, I have a question before we start. So you mentioned that all of this is on Google Cloud, right? And that we're using Kubernetes. Could you explain to us what are the benefits that we get from utilizing Kubernetes in this instance?
Absolutely. Because one of the 2 points of our main problems that we're addressing is scalability. Kubernetes is notoriously great at addressing scalability, because I can, for example, just change this number of replicas to scale from 3 to 5 nodes and say, hey, Kubernetes, increase the number of RabbitMQ nodes, and it will just automatically create those instances for me. And also it can do vertically scaling in a rolling fashion. So it's great for handling scalability, but also it's great for reliability, because here I have the desired state of my cluster and my applications. I'm not showing those particular configurations, but it's Kubernetes' responsibility to keep that desired state, such that if one of the nodes is not performing as expected, it can restart that node and do sort of self-healing capabilities built into the infrastructure. So thank you so much for that question.
Thank you.
All right, so let's jump. I have my terminal. We're going to be performing some commands. And ultimately, what I'm going to be doing is I'm going to be deploying those sync apps. So these sync apps are, a sync is just another way for us to, when I say sync, just think of it as a consumer, right? So this is the app that's going to talk and put the data into the Apache Geo database. I also have, and let me know if you can see this okay. But I have, this is the RabbitMQ instance. I have a port forward, so I'm able to reference this the dashboard, the admin interface from my local machine, and now I see that my consumers are now up and running and they have established their connection. As we mentioned, we have a dashboard. So this is we're going to provide a visualization of the actual vehicles. And we basically see there's no vehicles at the present time. I should show you really quick the definition. So this is basically the desired state of the application. Not going to spend too much time here, but it just basically has a unique name. You provide it with some connection details, some configuration details. How do I connect to Rabbit? And it's referencing an image within Docker Hub. And here I said that I want 3 instances of this consumer. And again, if I wanted to scale this up, I could just increase this number and provide and execute a CTL command. All right, so now let's deploy the generator. So the generator apps is very similar. I'm going to generate the random construction of 25 vehicles, and the statistics like the GPS and the speed is going to be randomly generated by this particular application. All right, so I just started that, and I could do, I have an alias for the kubectl command, which I just say K, because I don't want to keep typing kubectl over and over again. I could type fast, but K is faster. And then we have this app, now it's up and running. This is the generator app for the Fleet A information.
Hey, Greg, can you increase the font on that?
Yes, we'll do. So here now we see we have some, can you see this okay? Yep. So we see we now have some vehicles, right? And they are moving. And if you're worried about, if you have a question about the color coding, this is the color coding based on the temperature of the vehicle. So if it's over a certain threshold, it will be red, or otherwise it'll just be blue. All right, so now we have that, we have those vehicles up and running, and they are moving across the country. If I look at the connections, I see I'm getting some traffic that's being generated. And if I look at the actual queue, the consumers, they created this quorum queue. Now, quorum queues are, as there was already mentioned, I believe before, this is our recommended queue whenever you are doing any sort of replication or copies of messages, because it's implemented the RAF protocol, so it has an improved reliability built into the actual messaging protocol. So I have one quorum queue, and I have a dead letter queue. And dead letter queues are a good practice if there's, for example, a message that gets into the queue where the consumer can't process it because it has a bad format, for example, it would just move that over to the dead letter queue. All right. Now, what I can do also is, I got timed out. Let me go ahead and log back in. Okay. So now what we're going to do now is we're going to increase the we're going to introduce another producer. So this is the case where, for example, maybe you have another source of your application, your vehicle data, and this will be funneled to the same set of consumers that were previously running. And as Demetrious mentioned, I'll make sure that I increase this font. And now you see, you may have noticed that our throughput has doubled. So it was about 4,000 messages per second. It just went up to about close to 10,000 messages per second. We see now that we have more messages on the map. And you see now that they basically just have a prefix of fleet B. All right, so now that was really scalability. So we were able to scale up the number, introduce a new producer. We could easily scale up the number of brokers. We could easily scale up the number of consumers, all using this infrastructure. So let's go ahead and for the next part of this demonstration, I'm going to stop the generators, because one of the purposes of our session today is to talk about Internet of Things. So Demetrious is going to walk us through the unique challenges of Internet of Things.
All right, thank you, Greg. And when we think about the Internet of Things, we have to think about edge computing. And that is where the computing operates on instant data that is real-time generated by sensors or users. Even with edge computing, where we have some source or producer sending out data to a central hub, you can think of, say, your car GPS sending information somewhere. Well, that can be hard to implement reliably due to limited resources. And that could include anything from network bandwidth, limited memory, limited CPU cores, or even your good old-fashioned internet connectivity loss. And take it over to Greg.
Yep. So, and as Demetrious mentions, we want to show you addressing some of those concerns that were highlighted from Demetrious from another demo. So in this case, we're going to introduce an edge-based vehicle source. In this case, the edge is my local laptop. So we're going to start up Rabbit locally on my machine using Docker. We're going to have a generator app running on my machine, and it's going to use the Shovel plugin to move messages from the edge to the broker instance running in Google Cloud. If you're not familiar with Shovel, Shovel is basically, you can think of it as a built-in application into the actual cluster, such that it tries to move messages from one cluster to another. If it cannot move them successfully, if it doesn't have those acknowledgements, it will keep those messages and only move them when it's actually been acknowledged by the destination cluster that those messages are available or have been sent over. So as mentioned, we're going to start up Rabbit on my machine in Docker. The generator app that I'm going to be using is still going to be sending the same vehicle information, but it's going to use the MQTT protocol to send to Rabbit locally, and then shovel it over to the cluster.
Hey, Greg. So like earlier, our first demo, I noticed that we use AMQP. So like for this one, could you tell us why we're going with MQTT?
Yes, sir. One of the reasons why you will want to consider MQTT is because as Demetrious pointed out, you have limited resources on the edge, right? You want to make sure that there was a session right before this talking about the retail example, built in an edge-based example. And you want to limit the actual payload that's being sent over the wire. And MQTT is notoriously known as a great protocol in terms of limiting the actual payload that goes over the network wire. And also, there's a lot of devices, sensor information that have built-in support for communicating over MQTT. So that's one of the two reasons why we want to utilize this particular protocol with this example. But the great thing about Rabbit is it supports multiple protocols, right? It supports STOMP, HTTP, AMQP, the various versions of AMQP, and streaming, which we're going to show in a little bit. But before we go ahead of myself, let's go ahead and let's go back to the prompt. And I'll go back to the README, which has the examples step-by-step things that we want to introduce. So what I'm going to do here is I'm going to simulate a connection to GCP and using port forward. The reason I'm doing this is going to allow me to shovel running on Rabbit running on my laptop to the Google Cloud. The reason I'm using port forward is because I want to be able to test the reliability for this. Normally, you would expose Rabbit through some sort of load balance endpoint, but again, just for the purposes of this demo, we're going to use a port forward. And this is the details for starting RabbitMQ within Docker. Just some things I just want to highlight is that I have a file on my machine that specifically enables the shovel plugin. This will expose the MQTT port and also allow me to connect to the dashboard over this port. And I'm using I'm using the same image that we use for deploying Rabbit in GCP, which is basically the image that has the streaming plugins enabled. What I will do now is actually, let's just provision a user. So I will establish a bash connection let me minimize some of these other windows and maximize this. All right, so now we got a bash shell into Docker for Rabbit. We'll create an MQTT user and we'll put the password as the same thing. And as I'm doing this, this is basically just setting up permissions. We're going to declare a queue. But security is a huge, another concern whenever you talk about Internet of Things and Edge, and we're not going to do it any justice in this particular session, but you want to make sure that you are doing things like limiting the resources for the actual users that you're provisioning, having some way to introduce TLS and have some way to rotate credentials, so and things of that nature. Now I have the user. Now what I'm also going to do is I'm going to declare a quorum queue. And in this case, the quorum queue is going to be bounded to this exchange. And again, if you're not familiar with Rabbit's implementation of MQTT, the clients send all of their communication to this exchange. And the routing key that's used will match whatever topic name that the client is using. But in this case, we're just giving it a wildcard, saying whatever routing key you use, hey, just move the messages into this queue. And what we'll do also is we'll enable the shovel plugin. So the shovel will say, all of the messages that are sent on this sync, move it over using AMQP to, in this case, is going to be, actually it's going to go to this port forward first, and then it's going to send it over to Rabbit running in GCP. All right, we can open up the connection in Safari, because I just want to make sure I use another browser, and I'll use that MQTT user to log in. I think I missed a step to make sure that we set the tag for the user. So I'll go back in here and copy this and paste it here. So now I should be able to go back to Safari and log in. Okay, good. All right, so now we have, we can let a connection. So we don't, what we have now is the shovel. It's active. We don't have any actual applications. So moving on down, what we'll do is we'll start up the application. So I'm actually already in this directory. And again, this is just it's a Kotlin-based Spring Boot application that's going to generate that vehicle information. It's going to send that to the local RabbitMQ cluster. And it's already starting to process some data. I see I have the user, I have the connection. And if I look at the exchanges, I see that some messages is being sent over to the exchange that we mentioned. And if I look at the queues, we see that we have some traffic, right? Now, the number of ready queues is 0. That means that those messages are being immediately shoveled over to the cluster running in the cloud. So if I open up the management, this is the dashboard, the management UI running in the cloud. Now I see those messages coming over. And if I look at the dashboard, let's refresh the dashboard. So I see this vehicle, and we're getting up the live updates from that vehicle, and it's moving across the country. All right. So now what we want to do now is we want to demonstrate the reliability of this built into the framework. So what would happen here if I cut the connection from the edge to the cloud, which happens all the time, right? So what I'm going to do that, I'm going to kill this port forward. So now basically Shovel cannot move the messages over to the cloud. If I go back in here, we see that the number of ready messages is now increasing, right? It was 0 before, now it's steadily increasing. And we put definitions into the queue such that it will constrain the number of messages that are retained on the edge. And that will be based on the use cases. Like, for example, if you wanted to stop the app or you wanted to remove older messages, what we're doing is removing older messages. So we keep the latest and greatest up to a certain point. If I look at the actual traffic in Google Cloud, I see no traffic coming. And of course, the vehicle is no longer moving, right? Because we broke that connection. But the great thing is that as soon as I reestablish that connection by restarting this port forward, the Shovel, which I didn't have to write any code for, it's going to start reconnecting and reestablishing and resending those messages back over. So that now if I'm looking at, this is the admin on the edge, you see those ready messages went down to 0 because it already caught up. And now if I look at, now I see the messages are being shoveled over, being processed. And if we look at the dashboard, the vehicle is moving again. All right, so good. So now we were able to show you some of the details on how you actually recover from a network outage. Let's go ahead and let's go to the next part of this, which is really the last part. This is the last part before we open it up for questions. I think we're doing good on time. I'm sure there's a lot of questions that you have. But we want to talk about streaming a little bit because it's the brand new fancy toy within RabbitMQ. And think about, when you think about streaming, think about event logging. And some of you might be familiar with Kafka. So it's what Kafka sort of does. where a consumer, when he receives a message, instead, when he acknowledges that he received a message, instead of that being a destructive operation, it's really sort of like it's a pointer to the cluster to say, hey, I will keep track of the point in time up to which messages that you have acknowledged that you have received, such that a client can also have the choice to say, hey, Rabbit, I want you to replay all of the messages that you sent me, or up until a point in time. And this is really good, especially when you start talking about telemetry information, being able to build databases like, for example, was talked about, like a time series-based database, or introduce new data sources that just can connect to an existing stream and just have that information funneled down to them, right, in a very simple manner. The team has done an outstanding job, such that the throughput that is supported by the new streaming protocol has been dramatically improved. I think in some cases, they were saying like you can get like 1 million transactions per second. And also you can implement large volumes of messages with very little memory overhead, which is huge, right? Because sometimes you can overrun the cluster and you can run out of memory. So this is really optimized to store that data optimally on disk. And what's not mentioned here, but is also a huge benefit, is if you have a large fan out, meaning you want multiple consumers to receive your messages. Previously, you had to have separate queues for each one of the consumers. But with streaming, you don't have to have that. Basically, the consumers would just have a unique name, and then the name associated with the offset is what's stored in Rabbit. So it's much more optimum to implement large fan out requests. All right, so for our last demo, this is what we already have. This is what we already shown. What we're going to introduce is now introducing a new data store. In this case, we're going to use one of the most popular or open source relational databases called Postgres. And we're going to have a consumer that's going to talk the streaming API. And he is the expert in knowing how to move this vehicle data into Postgres, so we can do things like looking at the average speeds, the maximum speed, so on and so forth. And we're going to introduce a new edge deployment. So we're going to have another RabbitMQ deployment running in Docker on my laptop. It's going to have a new generator app. Again, it's going to use the streaming API to push that information into Rabbit. And then Demetrious and I rewrote our own. It's not exactly Shovel, but it's a sort of a custom implementation of Shovel, and it implements the same principles, where it's going to reliably move those messages from the edge to Rabbit and using the streaming API. All right, so let's jump back to here. What we're going to do now is we're going to deploy that sync app, and it's using JDBC. It's really using Spring Cloud data, and I say git pods.
I'm just going to mention that it's 5 minutes left.
Okay. Yeah. Yep. Okay. So let's speed this through. So those pods are being created. All right. And now they are running. Yep. They are running. I'm going to run RabbitMQ on my machine, another RabbitMQ. I'm going to open up the URL in Firefox. Yeah, like I said, we have a lot to show you. A little bit of time, trying to squeeze in as much as possible for for you guys. So this is going to take a little bit to start up. A little bit of time to start up. Let's see, did it start up already? Okay, started up. Just for to speed this up, I'll log in as the guest user. And just as we did before, we're going to use port forward. And this is going to forward. It's going to expose our local edge processes to move these messages onto Google Cloud. And then we're going to provision some things on the Docker instance. So basically, just as we did before, we're going to create a user. We're going to give it some permissions. I don't necessarily need to give it a tag because I'm not going to log in through the dashboard, but I'll just do this anyway. And then we'll start up the app. And I need a new shell, so I'll start up a new shell. Make this a little bit bigger. Okay, CD there. And this is, again, just another Spring Boot app to generate data. Actually, this is the Shovel app. So this is the guys that are actually removing the data across. If I do I have a client already set up, I could do a select to get the data. And I see I have no data in Postgres. This is actually running in GCP. If I go ahead and now I start the generator app. So we'll split this real quick. CD to here. Start the generator app.
Hey, Greg, you got a CD in there again? Yeah. Just
okay.
Yeah.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you. Right out of time.
You keep pressing CD, but it's on the clipboard.
Yeah. Sorry. All right. So start this generator app. All right. So now we should essentially be we're getting some traffic. We should start seeing some messages. Yep, we got some messages. If I keep doing a select, those messages are being sent over and being updated in real time. If I were to kill the connection, this is killing the connection to GCP. It's the same thing as before, right? I basically don't see any updates. I'm doing a query. I don't see any updates. I'm not, and then when I reestablish this port forward, the connections just reestablish themselves, and I should eventually start seeing some updated messages. There you go. All right, that's the end of the demo.
Nice. Thank you very much. And we have about a minute here for Q&A. Let's start with which IoT best practices have you seen missing in the field?
Which, I mean, not necessarily missing, but challenging. And that's the whole provisioning, the whole security issues. That's really, I kind of see as a sort of an easy way to manage deployments on the edge is that simple in open source is something that I think that needs to be addressed, needs to get some more attention, more love.
Yes. Okay. Do you have any tips for handling tens of thousands of unique connections if you have a very large number of connections?
Yes. And actually the streaming API does do a good job of increasing the number or addressing the number of connections. But I also will say that the product team is specifically trying to introduce this in future versions of RabbitMQ. We know that that's an issue, especially for MQTT clients, because there can be lots of devices connecting to a single cluster. So I would say streaming first, and then look forward to some new sort of improvements that's going to be introduced into Rabbit coming soon.